Modern cars pack more technology than ever before, but not all of it makes your life easier. While automakers market these innovations as cutting-edge improvements, experienced mechanics tell a different story. After analyzing thousands of repair orders, warranty claims, and consumer reports, a clear pattern emerges. Flashy features that fail early, drain your wallet, and leave you calling for roadside assistance. From electronic systems that never sleep to plastic parts that crack under pressure, these so-called improvements often create more problems than they solve. Some features are so problematic that manufacturers are quietly removing them from upcoming models. If you value dependable transportation over gimmicks, here's what to watch out for. Number 25. Start-stop engine systems. Every red light becomes a stress test for your engine with start-stop technology. This system automatically shuts off your engine when you brake to a complete stop, then instantly restarts when you release the brake pedal. The promise sounds appealing: better fuel economy and reduced emissions during city driving. The reality hits your wallet much harder. Each restart cycle hammers your starter motor, drains your battery faster, and cuts oil circulation when your engine components need lubrication most. Traditional engines were designed for maybe 50,000 start cycles over their lifetime. Start-stop systems can triple that number, pushing components far beyond their intended limits. Battery manufacturers had to develop expensive AGM batteries just to handle the constant cycling. When these fail, replacement costs jump from $150 to over $400. Starter motors burn out early, often requiring $800 to $1,200 repairs. Meanwhile, that fuel savings amounts to roughly $75 annually for most drivers, wiped out by a single component failure. Ford recalled 270,000 Bronco Sports for start-stop malfunctions that left drivers stranded. Honda Pilot owners report similar issues in heavy traffic. Most vehicles offer a disable button, but many drivers resort to aftermarket modules that remember the offsetting permanently. Number 24. Over-the-air software updates. Your smartphone updates seamlessly, so why shouldn't your car do the same? Over-the-air updates promise to fix bugs, add features, and improve performance without visiting a dealership. When everything works perfectly, it's genuinely convenient. The problems start when updates go wrong. A weak cellular signal, low battery voltage, or simply opening a door during installation can corrupt critical systems. Unlike your phone, a bricked car leaves you completely stranded. Tesla owners have experienced completely black dashboard screens after failed updates. Polestar drivers report frozen climate controls that require dealer intervention. Mazda issued warnings about $1,500 infotainment repairs caused by interrupted downloads. General Motors had to halt Blazer EV deliveries when software glitches prevented cars from shifting into drive. Ford recalled over 200,000 vehicles because a single over-the-air patch disabled backup cameras system-wide. These aren't isolated incidents. They're predictable failures when complex software meets unreliable wireless connections. Smart owners skip non-essential updates, ensure strong Wi-Fi signals before starting, and never update with battery voltage below 12.4 volts. One corrupted download can turn your daily driver into an expensive paperweight. Number 23. Electronic door handles. Flush mount door handles create sleek exterior lines, but they transform the simple act of entering your vehicle into a potential crisis. What used to require a basic mechanical lever now depends on tiny motors, fragile sensors, and temperamental wiring. Winter weather reveals the biggest weakness. Ice buildup jams the mechanisms, dead batteries disable the motors, and frozen sensors stop responding entirely. Tesla pioneered this design flaw, and other manufacturers eagerly followed with predictable results. Ford recalled 200,000 Mustang Mach-E's because low battery voltage could trap passengers inside the vehicle. Volkswagen ID4 drivers reported doors opening unexpectedly during turns. Tesla charges up to $880 per handle replacement after warranty expiration, assuming parts are available. Emergency situations expose the deadliest flaw. During crashes or electrical failures, these handles often stop functioning when escape becomes critical. Many vehicles bury the mechanical backup release in obscure locations that panicked occupants will never find. Base trim levels with conventional handles suddenly look like the smart choice. Always locate your vehicle's emergency door releases before you need them in a life-threatening situation. Number 22. Haptic touch controls. Glass panels replacing physical buttons create a futuristic cabin atmosphere, but haptic feedback systems fail consistently in real-world conditions. These smooth surfaces rely on pressure-sensitive layers beneath the glass that detect finger placement and respond with subtle vibrations. Heat, UV exposure, and natural skin oils gradually damage the sensors. After 2 summers, surfaces often develop bubbles, dead zones, and false triggers. Wearing gloves renders the system completely useless since it requires skin contact to register inputs. When haptic panels control essential functions like climate control, defrosting, or hazard lights, their failure creates genuine safety hazards. Tesla screen replacements cost $2,500, while Cadillac's Q system repairs can reach $1,800. Many independent shops refuse these jobs, forcing expensive dealership visits. Volkswagen quietly returned to physical buttons in the 2025 Golf after customer complaints. Other manufacturers continue pushing haptic controls despite mounting reliability concerns. Experienced drivers carry capacitive styluses just to regain basic vehicle control. Number 21. Active grille shutters. Behind your front grille, motorized louvers automatically open and close to balance aerodynamics with engine cooling. During cold starts, closed shutters help engines reach operating temperature faster. At highway speeds, they reduce drag for better fuel economy. The execution creates more problems than benefits. These plastic assemblies sit directly behind the bumper, exposed to road salt, debris, and impact damage. A single bent slat or frozen actuator can jam the entire system, starving your engine of cooling airflow. When shutters stick closed, engines overheat rapidly. Cooling fans run constantly. Temperature gauges spike into the red zone, and reduced power mode activates on busy highways. Repair costs typically range from $500 to $1,500, often requiring front-end disassembly just to access the mechanisms. Cold climate drivers face the worst reliability issues. Salt corrosion, ice buildup, and debris accumulation cause frequent failures. Diagnostic code P059F specifically indicates shutter problems, a red flag when shopping for used vehicles. Regular maintenance means inspecting the grille area with a flashlight during oil changes. Rinse the entire front end thoroughly before winter startup to prevent ice damage. Number 20. Wet timing belts. Traditional timing belts run dry, relying on precise tooth engagement to synchronize engine components. Wet belts swim in engine oil, promising quieter operation and reduced friction. Ford and Stellantis embraced this technology to meet fuel economy standards. The engineering sounds logical until rubber meets reality. Oil-soaked belts deteriorate from the inside out, shedding fibers that contaminate the entire lubrication system. These particles clog oil pickup screens, starve bearings of lubrication, and destroy turbochargers. Belt failure doesn't give warning signs. The rubber simply disintegrates during normal operation, allowing pistons to collide with valves at engine speeds. This interference engine damage typically costs $5,000 to $8,000 to repair, if rebuild parts remain available. Ford has recalled over 140,000 vehicles for wet belt failures, but damage often extends beyond the belt itself. Contaminated oil systems require complete flushing, new turbos, and sometimes full engine replacement. Preventive replacement between 50,000 to 80,000 miles using only full synthetic oil can extend belt life. Chain-driven engines avoid this problem entirely, making them preferable for long-term reliability. Number 19. Air suspension systems. Air suspension promises the ultimate ride quality, smooth highway cruising with adjustable height for different driving conditions. The system uses rubber air springs instead of conventional coils, controlled by compressors, valves, and multiple sensors. Complexity breeds failure points. Air springs develop pinhole leaks that slowly lower one corner overnight. The compressor runs continuously trying to maintain pressure, overheating and burning out its motor. Water infiltration corrodes internal valves and freezes in cold weather. Single air spring replacements cost up to $2,100, while compressor failures add another $1,500 to $2,000. Many owners face continuous repair cycles as aging components fail in sequence. Total system replacement can exceed $8,000. Fed-up owners often convert to conventional coil springs for under $1,200, accepting slightly firmer ride quality for bulletproof reliability. Others extend air system life by draining moisture traps regularly and switching to nitrogen inflation. Number 18. Electric water pumps. Traditional belt-driven water pumps provide reliable coolant circulation as long as the engine runs. Electric pumps operate independently, allowing post-shutdown cooling for turbochargers and more precise temperature control during warm-up. The advantage becomes a catastrophic weakness when electronics fail. Mechanical pumps leak when they die, providing obvious warning signs. Electric pumps simply stop circulating coolant without any external indication until your engine overheats. These failures strike without mileage-based predictability. BMWs, Audis, and even reliable Toyotas have experienced pump failures around 50,000 miles. Plastic housings crack, control circuits short out, or motors seize internally. Engine damage from overheating typically costs $6,000 to $12,000 to repair properly. Electric pump replacement runs about $2,200, but must be completed before catastrophic failure occurs. Experienced owners replace pumps proactively around 60,000 miles rather than gambling with engine destruction. Temperature gauge vigilance becomes critical since these systems fail without warning. Number 17. Sealed tire pressure sensors. Every new vehicle sold in America since 2007 includes tire pressure monitoring sensors mounted inside the wheels. These devices use small lithium batteries to power radio transmitters that alert drivers to dangerous pressure loss. Battery life limits sensor functionality to roughly 7 years. When batteries die, the entire sensor requires replacement since the units are permanently sealed. A complete set costs $400 to $1,100 plus programming fees that can reach $80 per wheel. Cold weather triggers frequent false alarms as tire pressure naturally drops. Drivers begin ignoring the warning system, defeating its safety purpose. Sensor failures often cascade. Replacing one sensor typically means the others will fail within months. Smart maintenance means replacing all 4 sensors simultaneously to avoid repeated labor charges. Non-metallic valve caps prevent corrosion that can turn a $3 part into a $300 emergency. Number 16. Brake-by-wire systems. Traditional hydraulic brakes provide direct mechanical connection between your foot and the brake pads. Brake-by-wire systems insert computers, sensors, and electric motors to blend regenerative braking with conventional friction. When functioning properly, the integration feels seamless and improves energy recovery. Electronic failures eliminate your primary safety system without warning or backup options. Tesla drivers have reported complete brake loss during normal turns. Mercedes recalled over 200,000 vehicles for brake system failures during routine driving. General Motors halted Corvette deliveries when brake modules failed on brand new vehicles. Repair costs often exceed $3,000 and require factory-level diagnostic equipment that independent shops don't possess. Voltage drops from aging 12-volt batteries can trigger system failures at the worst possible moments. Preventive maintenance means replacing 12-volt batteries every 4 years and flushing brake fluid religiously. Used car buyers should demand comprehensive brake system scans before purchase. Number 15. Run-flat tires. Run-flat tires eliminate roadside tire changes by allowing continued driving after air pressure loss. The reinforced sidewalls support vehicle weight for approximately 50 miles at reduced speed, providing time to reach a repair facility safely. This convenience comes with significant compromises. Run flats weigh 20 to 40% more than conventional tires, reducing fuel economy and electric vehicle range. The stiffer construction transmits more road noise and impacts directly to the suspension system. Most run flats cannot be repaired after punctures, especially near the sidewall. Each tire costs $200 to $450 to replace, with limited availability at most tire shops. BMW and Mini drivers regularly experience multiple rim fractures before 10,000 miles due to the harsh ride quality. Suspension components wear faster under the additional weight and reduced cushioning. Total ownership costs often exceed conventional tires with a compact spare tire setup. Many owners convert to standard tires and carry emergency repair kits or compact spares for better long-term economics and ride comfort. Number 14. Electronic shift controls. Push-button and rotary dial gear selectors eliminate the traditional shift lever, freeing up console space for storage and creating a modern cabin appearance. Electronic signals replace mechanical linkages between the shifter and transmission. Failure modes multiply when electronics control critical functions. Spilled beverages, worn switches, or dead batteries can trap the vehicle in park position. Unlike mechanical shifters with direct connections, electronic systems provide no backup method for gear selection. Hyundai and Ford owners frequently experience long waits for replacement parts when shifters malfunction. Repair costs range from $900 to $1,500, assuming dealers can obtain the necessary components. Emergency procedures for accessing gear selection during electronic failures remain buried in owners' manuals that most drivers never read. Learning these procedures before experiencing a breakdown can prevent being stranded in parking lots or driveways. Traditional mechanical shifters on base trim levels often prove more reliable and cost-effective over the vehicle's lifetime. Number 13. Multi-speed transmissions, 8 to 10 speeds. More gear ratios. Promise improved fuel economy, smoother acceleration, and reduced engine noise at highway speeds. Automakers squeezed 8, 9, and even 10-speed transmissions into the same physical space previously occupied by 5-speed units. The additional complexity requires more clutch packs, planetary gear sets, and electronic controls packed into tighter spaces. Components operate under higher stress levels, with thinner safety margins for heat and wear. These transmissions often exhibit harsh shifting, delayed engagement, or unexpected neutrals before reaching 30,000 miles. Ford, General Motors, and Stellantis products have documented reliability issues requiring complete transmission replacement. Rebuild costs range from $5,000 to $9,000 when failures occur outside warranty coverage. Parts availability becomes problematic as manufacturers discontinue support for complex units with limited production runs. Preventive maintenance requires fluid changes every 40,000 miles instead of manufacturers' lifetime claims. Early intervention at the first signs of shifting irregularities can prevent complete transmission destruction. Number 12. Electronic parking brakes. Push button. Parking brakes replace hand levers with electric motors integrated into the rear brake calipers. The system automatically engages when the vehicle stops and releases when the driver accelerates. Motor failures lock the rear wheels permanently, preventing the vehicle from moving until expensive repairs are completed. Unlike cable-operated brakes that can be manually released, electronic systems offer no emergency backup procedures. Winter conditions prove especially problematic as salt water corrodes the small motors and freezes moving parts. Repair costs typically reach $2,000, including parts reprogramming and labor. Software dependencies create additional failure modes. Weak 12-volt batteries or corrupted updates can disable the parking brake entirely or prevent normal release. Proactive battery replacement every 4 years and thorough winter wheel well cleaning can extend system life. Traditional hand lever brakes on base models avoid these electronic complications entirely. Number 11. Smart charging alternators. Conventional alternators maintain constant battery voltage around 14.4 volts during engine operation. Smart charging systems vary output based on driving conditions, reducing electrical load during acceleration to improve fuel economy. The efficiency gains come at the expense of battery longevity. Smart alternators often maintain battery voltage between 11.9 to 12.2 volts, keeping the battery at 70 to 80% charge level that promotes sulfation and premature failure. AGM and EFB batteries required for start-stop systems cost $220 to $450, but typically last only 2 to 3 years under smart charging conditions. Owners often replace batteries multiple times before recognizing the charging system causes premature failure. Home battery maintainers can supplement inadequate charging during extended parking periods. Some owners reprogram the charging algorithms to restore conventional voltage regulation, trading slight fuel economy for battery longevity. Number 10. Sealed LED headlight assemblies. LED headlights offer superior illumination and longer service life compared to halogen bulbs. The technology promises decades of reliable operation with minimal maintenance requirements. Manufacturing reality differs significantly from marketing promises. Sealed LED assemblies cannot be repaired when individual components fail. Heat buildup, moisture infiltration, or electronic failures require complete headlight replacement. Single headlight assemblies cost $900 to $3,000 plus installation labor. Toyota, Audi, Ford, and BMW owners have experienced complete LED failures before 50,000 miles, often after warranty expiration. Base trim levels with replaceable halogen bulbs suddenly become attractive for long-term ownership. Research common LED failure patterns for specific models before purchasing vehicles with sealed assemblies. Number 9. Oversized wheels and low-profile tires. Large diameter wheels with thin tire sidewalls create aggressive styling that photographs well in marketing materials. The reduced sidewall height provides less cushioning between road impacts and expensive wheels. Every pothole, expansion joint, or curb contact risks wheel damage and tire destruction. Replacement costs for low-profile tires range from $200 to $450 each, while wheels can add another $600 to $1,200 when damage occurs. The harsh ride quality reduces comfort and increases suspension component wear. Electric vehicles suffer reduced range from the additional rolling resistance and weight of oversized wheels. Many owners downsize to smaller wheels with taller tire sidewalls after experiencing expensive damage. The improved cushioning and lower replacement costs make this modification worthwhile for long-term ownership. Number 8. Plastic engine components. Weight reduction targets led manufacturers to replace metal engine parts with plastic alternatives. Coolant expansion tanks, thermostat housings, intake manifolds, and oil pans now use plastic construction to meet efficiency standards. Heat cycling and pressure eventually cause plastic components to crack, warp, or completely fail. BMW expansion tanks rupture at stoplights, spraying coolant across engine bays. Ford plastic intake manifolds crack frequently enough to generate class action lawsuits. These failures typically occur between 60,000 to 90,000 miles without warning signs. Labor costs multiply the repair expense since many plastic components require extensive disassembly to access. Aftermarket aluminum replacements cost more initially, but eliminate recurring failures. Proactive replacement before failure prevents roadside breakdowns and potential engine damage from coolant loss. Number 7. Keyless entry and push-button start proximity sensors detect key fobs and automatically unlock doors when approached. Push-button starting eliminates the need for physical key insertion, creating a premium ownership experience. The convenience requires constant electronic monitoring that prevents vehicles from fully entering sleep mode. Modern cars draw 70 to 150 milliamps while parked, compared to 10 milliamps for older vehicles with conventional keys. Healthy batteries can discharge completely in 7 to 10 days from this phantom drain. Airport parking or extended storage often results in dead batteries that prevent starting, despite the battery's good condition. Relay attacks allow thieves to amplify key fob signals and steal vehicles in under 20 seconds. Insurance claims for keyless entry thefts continue rising as criminals adapt their techniques. Faraday pouches block key fob signals when parked at home. Battery maintainers compensate for excessive electrical drain during extended storage periods. Number 6. Soy-based wire insulation. Environmental regulations encouraged manufacturers to replace petroleum-based wire insulation with renewable soy-based alternatives. The biodegradable material reduces environmental impact during vehicle recycling. Rodents find the plant-based insulation irresistibly tasty, chewing through wiring harnesses that cost thousands to repair. Mechanics nationwide report increasing wire damage from mice, rats, and squirrels attracted to soy insulation. Honda owners have faced multiple wiring replacements exceeding $8,000 per incident. The damage often remains hidden until random warning lights appear or critical systems fail unexpectedly. Moisture wicking and heat brittleness affect soy-based insulation more severely than traditional materials. Wire mesh guards, rodent tape, and indoor parking provide some protection against animal damage. Number 5. Low-tension piston rings. Reduced piston ring tension decreases internal engine friction to improve fuel economy test results. The lighter spring pressure allows rings to move more freely during compression cycles. Lower ring tension compromises oil sealing, especially under vacuum conditions during deceleration. Oil consumption increases gradually as rings lose their ability to prevent oil migration into combustion chambers. Toyota, Subaru, and General Motors have issued recalls and extended warranties for excessive oil consumption caused by ring designs. Engine rebuilds cost $4,000 to $7,000 when rings carbon up permanently. Frequent oil level monitoring becomes critical since consumption often exceeds 1 quart per 1,000 miles. Thicker oil viscosity can temporarily improve sealing but may affect fuel economy. Number 4. Panoramic glass roofs. Large glass panels create an open, airy cabin atmosphere with dramatic sky views. The visual impact makes interiors feel significantly larger than conventionally roofed vehicles. Glass roofs trap substantially more heat than metal alternatives. Interior temperatures can reach 140 degrees Fahrenheit in parked vehicles compared to 104 degrees Fahrenheit with steel roofs. Air conditioning systems work harder to maintain comfort, reducing fuel economy and electric range. The additional weight sits high in the vehicle, raising the center of gravity and affecting handling dynamics. Glass weighs more than stamped steel panels, while providing less structural rigidity. Replacement costs range from $1,500 to $3,000 when glass panels crack or leak. Insurance coverage varies, and adhesive failures can develop over time as seals age. Metal roofs provide better insulation, lower weight, and substantially reduced repair costs for practical long-term ownership. Number 3. Tire mobility kits. Spare tire elimination saves weight and cargo space while reducing manufacturing costs. Tire mobility kits include small air compressors and sealant bottles designed to repair minor punctures temporarily. The limitations become apparent during real emergencies. Sidewall damage, large punctures, or wheel damage cannot be repaired with sealant kits. Tow trucks become the only solution when mobility kits fail. Sealant expires after 4 years, often without owner awareness. Using expired sealant can damage tire pressure sensors and wheel finishes. Some sealant bottles have been recalled for fire hazards during storage. Compact spare tires or tire plug kits provide more versatile emergency repair capabilities. The slight weight penalty proves worthwhile when mobility kits fail to resolve tire emergencies. Number 2. Capless fuel filler. NEX. Twist-off fuel caps disappear in favor of spring-loaded flaps that seal automatically after fuel nozzle removal. The system prevents cap loss and reduces vapor emissions during fueling. Dirt, sand, or debris can prevent proper sealing, triggering check engine lights for vapor leak detection. Replacement filler necks cost $100 to $220, plus labor charges that can exceed $600 total. Cold weather and impact damage can jam the flapper mechanisms, preventing fuel tank access entirely. Emergency fueling requires special funnels that most drivers don't carry. Regular cleaning around the flapper area and carrying the emergency funnel can prevent most problems. Aftermarket dust caps provide additional protection against contamination. Number 1. Always-on electronic systems. Modern vehicles never truly sleep thanks to remote connectivity, security systems, and comfort features that monitor constantly for activation signals. This electronic vigilance comes with hidden costs. Parasitic electrical draw has increased from 10 mA in older cars to 70 to 150 mA in current models. Healthy batteries discharge completely in 10 to 14 days of parking, not from battery defects but excessive electrical consumption. Tesla's Sentry mode can consume 8 to 10% of battery capacity daily while parked. Ford has issued service bulletins addressing overnight battery drain from remote access applications. Airport parking often results in dead batteries after week-long trips. Battery maintainers or solar chargers can compensate for excessive electrical draw during extended parking periods. Understanding which systems remain active and learning to disable unnecessary features can significantly extend battery life and prevent inconvenient starting failures. The next time you're shopping for a vehicle, remember that the most reliable cars often have the fewest electronic gimmicks. Sometimes the best innovation is knowing what not to include.